When modeling, an engineer is not just drawing shapes. Every step has a purpose. In this video, I will show how to think while modeling, what to evaluate, and how your decisions affect construction, electrical, and other teams. I already created a simple 6 by 6 meter axis grid just to have a reference. Now I quickly build a small room around it, so we are not modeling an empty space. Using the subtract command, I rapidly shape the walls, nothing fancy, just enough to understand the layout. In real projects, we almost never design equipment in the air. Pumps and tanks are always placed relative to something, existing buildings, structures, or defined coordinates. If it's a new area, we still need reference points to work with. That's why I always start with axes and basic walls. It gives structure to the model and makes every next step more logical. First tip, don't be lazy with layers. They might feel unnecessary at the start, but they always pay off later. I skip them sometimes, and I regret it every time. Our task is to place a tank and pump system inside an existing room. But don't place equipment blindly, and don't just drop it anywhere. If you do that, you'll end up with strange dimensions, like 2,056 millimeters between objects. Instead, place everything with intention. I usually start from a clear reference point, like the center, and move equipment by clean, logical distances, for example, 1,000 millimeters. If I need to adjust, I move it by another 100 or 200, not some random value. This way, your layout stays clean, predictable, and much easier to work with later. When placing a tank, always think about maintenance. How much space will you need to access it? If the tank is tall, will you need a platform? Will a technician be able to safely reach all components? As a rule of thumb, aim for at least 1 meter of clear space around the tank. 600 millimeters is the minimum. 500 only if you have no other option. The second component is the pump. And just like before, keep your distances clean. Don't place it randomly. Start from a clear reference point, like the center, and move it by logical values, 1,000 millimeters, 800 or 500. Avoid strange numbers. Clean distances make your model easier to understand, easier to build, and easier to modify later. And you won't feel uncomfortable when the main contractor asks, "What's the distance between these two elements?" And you answer, 1,569 millimeters. Keep your dimensions clean and logical, so your answers are just as clear as your model. Another question, does your pump sit directly on the floor? No, it should be placed on a foundation. Why? Because you need to raise it for better piping layout, proper drainage, and space for flanges and connections. Now, what type of foundation to use? It can be concrete or a metal frame. In this case, I will go with a concrete foundation. The foundation should be slightly larger than the pump frame, around 100 millimeters wider on each side. This gives enough space for comfortable bolt installation. Not too big, to keep it cost-effective, and not too small, so the bolts are not too close to the edge. One more thought from the system side. One pump is usually not enough. Typically, you need two, one in operation and one as a standby. So let's duplicate the pump and extend the foundation to support both units. Our tank is also standing on the ground. Sometimes, we can place it directly as it is, but in many cases, it's better to add a foundation. For example, a circular concrete base, about 200 millimeters high and around 200 millimeters wider than the tank diameter. This gives better stability, cleaner installation, and improves drainage around the tank. If you are a site layout engineer, your job is not to design the foundation in detail. Your task is to define the requirements and pass them to the construction team. They will calculate and design the proper foundation based on loads, soil conditions, and standards. I slightly move the tank away from the wall to create more space around it. Now, let's prepare a task for the construction team. At this stage, all equipment is placed on foundations in the layout. This step is often reviewed with the client. With one general arrangement drawing, you can actually do two things. First, send it to the client for confirmation. that the equipment positions are correct. Second, use the same drawing to create tasks for other disciplines like construction, electrical, and automation. Now, a quick note about layout and paper space. The tab in the bottom left is your model space. This is where you build your 2D plans or section views. Then we have layout or paper space. You can think of the title block like a screen, a window through which you look into your model space. One more tip: if your cursor moves in fixed steps, like a grid, and you can't select certain points, it means snap or grid is turned on. Just turn them off in the command line, and you'll get full control again. Do not leave equipment unnamed in your plan. Always add tags. In this video, I'm not focusing on tag formatting, dimensions, or other details needed for a fully polished drawing. Just the idea. In Model Space, you see everything as you draw it, without scale. But in the Layout tab, you see your drawing in a defined scale, like 1 to 100 or 1 to 50. You can think of layout as a sheet of paper on your screen, where you place views of your model and scale them properly for printing. Now let's get back from theory to our task for the construction team. I like to clearly highlight the items that need to be calculated by constructors. In our case, these are the foundations for the tank and the pumps. People should clearly see what needs to be done. First of all, dimensions. The dimensions of the equipment itself, and the distances from axes or other reference points. Be careful with dimensions and layout. You are not measuring the model directly. You are measuring through a viewport. Since the viewport has a scale, your dimensions depend on that view. Quick fix: when dimensioning in layout, always snap to model geometry. Don't pick existing dimensions or lines drawn in layout. Otherwise, your measurements may be incorrect. Do you see those strange foundation dimensions, like 1708 millimeters? That happens because we drew the rectangle based on the pump frame, and then just stretched it by 100 millimeters on all sides. The result, not very clean numbers. I prefer to adjust it to nice, rounded dimensions. It makes the drawing clearer and much easier to work with. I'll quickly adjust the foundation and regenerate the view. It only takes a few seconds. Let's finish the dimensioning and add the main information for the construction team. We need to specify the foundation height and the loads, how much the pump weighs during operation. It's also good practice to include a safety factor, so everything is designed with a margin. And if the pump has significant vibration, this should be clearly noted as well. About the loads, sometimes you don't have the exact equipment yet. In that case, create a task for construction based on an estimated load. The best approach is to select a similar pump from catalogs and check its weight in the datasheet. This gives a reasonable approximation until the final equipment is defined. For pumps, a very useful tool is the Grundfos Product Center. I've already shown it in my previous videos. You simply enter your parameters, and the program selects suitable pumps for you. It's very helpful. You can also download the 3D model directly. What about the tank? There are plenty of tools online to estimate tank weight. You can also use basic formulas. For a cylindrical tank, calculate the top, bottom, and shell. For spherical tanks, it's usually faster to use online calculators. But the most important thing, construction always needs full loads. That means the tank with product inside. You already know the tank volume and the product density, so you can calculate the total weight. One more important thing, fixation points. You need to know where the equipment is anchored. For example, bolt locations for a pump, or support legs of a tank. If this is an early stage task, and the exact equipment is not yet defined, detailed bolting is not necessary. But once you have real equipment, you must specify bolt hole sizes and their exact positions. Now that the construction task is ready, we can create another one on the same plan. A task for the electrical team. In our case, the electrical equipment is the pumps. For the initial stage, it's enough to specify basic data like power, for example, 2 kilowatts. If you don't know the exact value, select a similar pump from the Grundfos Product Center and use the data from there. Later, the task should be more detailed. You need to specify the current and the power supply. In most cases, pumps use 3-phase power, typically 400 volts. 3-phase means the load is distributed across 3 lines, which is more efficient and stable for motors. While the electrical engineers and the construction team are busy, let's create a task for the architectural team. And of course, we continue to develop our 3D model in more detail. The equipment is already in place, so now we can start adding the piping. Let's connect the pump to the tank. It pulls fluid from the tank on the suction side and pushes it further through the system. In this video, I'm not going deep into detailed 3D modeling. The goal is to show how a project is developed, how tasks are created, and what I'm thinking while modeling. And here we can see where the architectural team needs to be involved. We have a pipe crossing the wall, so we need to create an opening. I cut the required space around the pipe, and this becomes another task for the architectural team. How much space should we leave? Around 100 millimeters of clearance is usually a good starting point, but always consider insulation as well. If the pipe is insulated, you need to increase that space accordingly. How do we finish these openings? There are different solutions. A typical method is to fill the gap with rock wool and seal it with mortar or fire-resistant sealant. Don't be surprised. Sometimes, on site, workers will ask for drawings showing how to seal these openings. In many cases, they may end up doing it themselves. Let's get back to the architectural task. I've already created the plan. One note about AutoCAD Plant 3D. If you create multiple plans from the same area, they will all be placed in the same location in model space. In that case, I simply move them away from each other. So in model space, I have separate plans. Now I measure the opening in the wall. Now I draw a few lines to clearly show the size of the opening. This way, the architectural team knows exactly what diameter hole to prepare. This information is also important for the construction team because there may be structural elements, like beams, in that location. And add a clear note describing what the task is about. This helps everyone quickly understand what needs to be done. Since I added 100 millimeters on both sides, I ended up with a strange opening size, 368 millimeters. That's not something you want to say on a construction site. So I round it, first to 370. But in this case, 400 millimeters makes much more sense. Clean, simple, and practical. Now I add a section view for better understanding of the opening, its exact location and how it looks. In section views, I often include axes and align them with other views. This keeps the layout structured and everything clearly aligned. That's it for this part. We'll continue in the next video. If you found this useful, subscribe to the channel and leave a comment below.